Well, good morning, everybody. We are almost done. We really are. We're going to be finished tomorrow. I'll give the last thing will be the test tomorrow. And if you have everything in, regardless, if everything's in, you will get an A, okay? I don't even care about the grades that you got on those things. If you have everything in, you're going to get an A. Now, if you don't have everything in, you should, because what an easy A, okay? All right, here's yesterday's homework. Here's what I did on number 1. I found the area of this by finding, I knew that all of these angles were 72, okay? And so 3654, and so the answer is 110.1. 2 angle P is 27, that was easy, and then I used, I think it was sine or cosine. A little p would be this side opposite of angle P. I had that to be 7.13. Little g, which is I just probably used Pythagoras theorem to get little g. I could have used sine or cosine to get a 15.7. On this one here, what I did is I found the angle by using cosine inverse adjacent over hypotenuse. Get about 54 degrees, and then I subtract from 90, you got C. Little a, I probably used Pythagoras theorem to get a 13.7, okay? On the back side, my isosceles triangle, so I cut it straight down the middle, and that's 24, that's 66. So I probably use tangent, tangent of 66, h over 8. So I got the height would be about 18, so then the area is 1/2 base times height, and I got about 144 centimeters squared. Here's my 5-foot boy, angle of elevation 65 degrees, and so what I do is you have to remember to add in the 5, because I think I got about a 64. This is 64.5, but you got to add in the 5 because the 5-foot boy, right? 5-foot boy, okay? And then 25 angle of depression, which is right here, and you use opposite over adjacent, which is tangent. So tangent inverse, because we're looking for the angle, always inverse if you're looking for the angle. I got about 4.7 degrees, okay? Now, here's today's review, okay? And if you need a copy of it, you can send me a copy if you just want to get it from this film. Here's how it works, okay? So ratios. Ratio means fraction. So if I do angle A, if I do sine, let's do B, and you guys can do A. Sine of B is going to be 6 over 10. Let's write those down. Sine theta is opposite over hypotenuse, right? Cosine of theta is adjacent side over the hypotenuse, right? And tangent of theta is going to be simply the opposite over the adjacent, okay? And have those written down somewhere. You're going to need to know those, okay? So let's do B, and I'll let you do A, okay? B is opposite over hypotenuse, 6 over 10. Okay, leave it like that. I just want the ratio, okay? Cosine of B is adjacent over hypotenuse, 8 over 10. Tangent of B is going to be opposite over adjacent. Opposite over adjacent, 6 over 8. Now when you do A, angle A, which I'm going to have you do A, sine of A, cosine of B, the opposite is the 8, right? Because you went to the other side of the lake, called the triangle lake, and all of a sudden if you're on the other side of the lake, that's my opposite side and that's my adjacent, okay? So you guys need to do sine of A, cosine of A, and tangent of A, okay? I'll show those answers tomorrow, okay? 2. So first of all, if I take a look at this triangle, I have to find everything. Everything. That means I have to find angle C. I've got to find little t. That's the name of the side opposite angle T, and I've got to find little c. Well, let's find the easy stuff first. I think the easiest is angle C. So just 90, angle C is 90 degrees minus 54. Okay, I'll let you guys do that. Oh, I'll do it. What the heck? 90 minus 54, because I might need that information. 36 degrees. Okay, and then let's find T. So I'm going to go to my angle. That's my opposite side. And that's my hypotenuse. So let's go opposite hypotenuse. Opposite hypotenuse has got to be sine, and theta is 54 degrees. So I'll go sine of 54 equals, let's see, opposite over hypotenuse, that's going to be 10 over t. Now remember, if the t's on the bottom, I'll multiply it up, bring up the t, multiply up the t, but then I've got to divide by sine of 54. So I'll have t equals 10 divided by sine of 54. Whatever that answer is. I guess I could do it. I don't really want you guys to do some of this, right? I don't want to do it all for you, but I guess I could. 12.36. And then probably You can find C by cosine or by Pythagorean's theorem. Okay, I'll let you guys do that, okay? 3, first thing I would do is probably find this angle P, right? And so from angle P, that's throw the rock to the opposite side. That's my opposite. That's my hypotenuse. I'm going to set up, let's see, opposite hypotenuse. Opposite hypotenuse has got to be sine, right? So I'm going to set up my sine of theta, but sine of angle P is equal to my 5 over 13. Remember, inverse. If you need the angle, inverse button, okay? Look, 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 look. The inverse button. That's the blue ones. Those are your find the angle buttons. You want to use these sine to the negative 1. These are find the angle buttons. So I'm just going to go sine inverse, right, of 5/13, and watch what happens. 5 divided by 13, and I get an answer of about 22.6 degrees, okay? So angle P is 22.6 degrees, because you have to use sine inverse, that little button, of 5 over 13. Degree mode, right? Degree mode. If you're not getting these answers, check your mode. Ask me and I'll show you how, okay? And I'll let you finish it up. Once you get this to be 22.6, you can get this from 90, and you can get this side, little I, by Pythagorean's theorem, okay? You can finish that. Okay, page 2. Let's put some things up here. So we have 2 special right triangles. We have a 45, 45, 90. And if it's half a square, that means that these two sides are equal. 45, 45, 90 triangle. X, X, X squared roots of 2. So 45, 45, 45, 45, 90. It's half a square, so 12. X has to be 12. It's got to be 12. Okay. 12, 12. Look. X, X, X squared roots of 2. 12, 12. Y is 12 squared roots of 2. Sure, you could probably use some trigonometry to get it. Probably tangent, and then to get y, you could probably use maybe cosine, but either way, there it is. Okay, now, we have another special right triangle. Okay, the other special right triangle, I'll squeeze in here real quickly, and it is a, we call the 30, 60, 90 triangle. This side we call X, it's the short side, and this side's always twice as big. 2x, twice as big. Well, if that's 20, then that's 10, right? This side here is always whatever this is times the square root of 3. Now, if we're in my classroom, these are up on the board. You can see them, okay? So, this side is twice as big as this side. So this is 20. This side is 10, okay? This side is y, which makes it, has to be, whatever this is, 10. If this is 10, this is 10 square roots of 3. So this y is going to be 10 square roots of 3. Okay, got it? Again, you could use trigonometry as well. If you don't get it, you could probably use sine, and you could probably use cosine to get those values. Okay, now this one is exactly this triangle, but just turned on its side. It is still the 30, 60, 90 triangle. 30, 60, 90 triangle. This side is x, whatever that is. And this side is always twice as big as that. And this side is always some x squared roots of 3. Now, 12 is sitting where the x squared roots of 3 is, right? And I need to find x. 12 is sitting where the x squared roots of 3 is. So let's just set 12 equal to x squared roots of 3, and let's solve. Okay, well, I can solve that. Divide by the square root of 3, divide by the square root of 3, which makes 4 square roots of 3. Okay? So, if that's 4 square roots of 3, right, that's x. And this is twice as big, so this is 8 square roots of 3. Okay, there we go. Almost done, and then I'll have you guys work on this, okay? Number 5, this is, you have to be careful because it gives it in terms of inches and feet, okay? Now, a wheelchair ramp is constructed. Okay, now you ready? Here's the big thing that a lot of kids miss. 2 things kids miss, but you won't miss it because you're smart. This is the ramp. That's the ramp. This is not the ramp. That's like buried in the ground. This is the ramp, okay? Not this. So the ramp is 4 feet. So let's put everything in terms, to make it easier, let's put everything in terms of inches, okay? Well, 4 times 12, right, is 48 inches. So first thing I would do is change this to 48 inches. Okay, first thing I would do. And this is 9. Now, find the angle of the ramp. Well, that's theta right there. Okay, so what do we got? Opposite hypotenuse, opposite hypotenuse, opposite hypotenuse, opposite hypotenuse. It's got to be sine. So we said sine of theta equals the opposite, which is 9, over the hypotenuse, which is 48. Okay, now wait a minute. If we got to find the angle, remember, one more time. If you need to find the angle, to find an angle, you have to use the inverse buttons. If you want the angle, you have to use the inverse button. So I'm going to go sine inverse of 9 over 48, and I'll just use my calculator. Okay, so I want to do that. Okay, I'm going to go sine inverse. See it? The inverse button of 9 divided by 48, and I get an angle about 10.8 degrees. Okay, it's pretty steep for a wheelchair ramp, but that's it. Okay. 6, last but not least, find the area of this triangle. So what I'm going to do is it's called right triangle trick. So I'm going to make a right triangle, correct? Let's take a look at this. So I've got my right triangle. Let me superimpose that down here. Okay, and then this side is 12, and this is 65, because I took my 130 degree angle and I cut it in half, right? So I get 65 degrees, right? 130 divided by 2, boom, 65, right? Got it? 90 degrees, because it's the altitude. Okay, so here's what I need. To find the area of a triangle, I'm going to need its base and its height, okay? So I'm going to need its base and its height. All right, it really doesn't matter which one we find first. Gosh, let's find the base, okay? So the base is opposite over hypotenuse, right? From here, throw the rock to the opposite side. So opposite hypotenuse, okay, opposite hypotenuse, opposite hypotenuse, opposite hypotenuse is sine. So we'll sine of theta, but we know that theta is 65 degrees, right? So sine of 65 equals opposite, which is b, over hypotenuse, which is 12. Okay. Multiply up to 12, and I'm going to go 12 times the sine of 65 equals b, and I'm just going to use my calculator. Okay, what is 12 times the sine of 65? I'm going to answer of about 10.9. Okay, so the base for here is 10.9, but the whole triangle, let's double that, okay? Right? b equals 10.9, but I'm going to double that times 2, and I get an answer of about 21.5. So just use my calculator, double it, right? 21.57. So the base is 21.75. Now the height, what's the height? Well, I can use cosine because I've got my adjacent, right? And my hypotenuse. So adjacent hypotenuse is cosine, right? So let's go cosine of theta, but theta is 65, equals my adjacent, which is h, over my 12, multiply by 12. Okay, I'm going to go 12 times the cosine of 65, and I get an answer of about 5.07. Let's round that up to 5.1, okay? H is about 5.1, okay? Okay, now, area of a triangle, because that's what we're trying to do. Why do we need all this? Well, the area of any triangle is 1/2 its base times its height. Okay, so we're going to go area is equal to 1/2 its base, which is a 21.75, times the height, which is 5.1. Now we're going, just going to use my calculator, 0.5 times 21.75 times 5.1, and I get an answer about 55.46. I round it up to 55.5 in terms of centimeters. There you go, centimeters squared. Okay, so this is your homework. If you need a copy of it, or if you want to just take it from the film and show it to me, you can. But this needs to be done. We're almost done. Tomorrow's the last day of filming, and then we've got till Wednesday to get everything in, okay? So, there we go.